Hi, a viewer called Tam sent me these, which is a set of night vision binoculars, he called them, but I think it's more a monocular type of arrangement because one seems to be an IR illuminator and one seems to be a camera, so not quite binoculars, but anyway. So what happened with these was he was running them off a power bank via the USB socket at the side. And the power bank went flat, so he wanted to review some footage, so he plugged it into a mains adapter, one of these 5-volt USB adapters, and there was a bang and a flash, and now they no longer work. So I'm not sure whether we'll be able to repair these or not, but anyway, I've popped some batteries in there. So I've already put some batteries in there, the cursed Duracell ones, and let's see what it does. And it doesn't seem to be doing anything. Right, let's try a USB power bank and a USB lead and we'll see if it's drawn any current. Right, got a USB power bank here. Let's plug that in. And we'll just plug a lead into the USB socket. And it is drawing some power. I'll just zoom down a bit. It is actually drawing about 80 milliamps. Let's just see if it does anything when I try and switch it on then. Absolutely nothing. Right, okay, so they do not work. This is pretty much what he said. Right, let's see how they come apart then. Now I have worked on something like this before, and he did say he's had a look inside of it but couldn't actually see anything wrong with them. He couldn't see any sign of any blown components or anything, so let's take this part off first, I think. Let's find a Phillips screwdriver. Right, that's just a big lens in front of a LCD display. Let's pop that on one side. Now I wonder if I've got to take the whole thing apart or whether I can just undo those 3 screws. Let's see if I can just undo those 3. Oh, the screws don't want to come out. Right, I'll just undo them all and we'll see what happens. I still think we're caught on something here. There we go. We're sort of into it. Little camera module there, and that's the IR emitter. Let's see if this top part comes off now. Yes. Well, this looks a very similar design to one I looked at previously. I can't remember which one it was, but it does look quite familiar. So let's see if we're getting any power on the battery connector here. I'll just zoom down a little bit. I'll just move that along so I can get the meter in shot. And we'll just go into volts DC. Yeah, we've got 5.6 volts there. Looks like we've got a couple of little power supplies here. Actually, one will be for the driving of the LED here, and one will be probably regular power for the main processor and stuff, which will probably be under here. I've got another battery terminal here as well. Let's just check that one. We seem to have 2.8 on that one for some reason. Now why is that? I wonder if something's getting pulled down or something. Let's just try it disconnected. Still only 2.8. Right, I'll just investigate these batteries. Let's see what's going on here. Even though it should still work on the USB. I'll just zoom out a fraction. Let's just check these. Well, they're all okay, so why are we only getting 2.8 or whatever it was? Let's just try that again. All the battery terminals look okay. That's better. Let's just see if it'll switch on now. And the answer's still no. Nice. Let's just zoom down a bit and see what we can see then. Well, I can't see any signs of any blown components or anything on this side. So I think what I'm going to do, I'm just going to unplug this board. We'll just disconnect the battery connectors first. I'll disconnect the eye or illuminator. Remembering it goes on this side, it's actually marked, so that's okay. Let's undo these 4 screws and let's have a look on the other side of the board. And another windy night up in the hills it is. I don't know if you can hear the wind on the microphone there. I'll just move this down a little bit so we can get it a bit better in shot there. And I don't really recognise any of those ICs. Looks like we've got another little power supply just round about here with a little inductor. And looks like we've got a few power supplies here. So I guess that's where the power comes in, into each power supply. And we'll probably get an output on each of those capacitors. I'm just looking to see where the power comes in here. So that rail goes down to here, which seems to go through the board, through those wires. And it seems to go across the board there. To this point here. So I don't know if it's worth plugging the USB in. And we'll just see if we're getting power to here first and then over to here. I think I'll do that. Right, I shall just try and get this in some kind of a semblance here so I can plug things in. And I'll just zoom out a fraction so I can try and get the meter in shot as well. Right, so we'll just use this as a ground. Let's just see if we get any power here. And we do, we've got 5 volts. I've got 5 volts. Oh, we did have 5 volts. No, the power bank's automatically switched off, I think. I'll switch that back on again. I think it's just switched off again. Yeah, that's annoying. Yeah, it's not drawing any current now when I plug it in. So I don't know whether it was trying to draw some or trying to charge some batteries maybe, which isn't very good. Well, we do get 5 volts to all of those regulators. Let's just see if we get anything on the output of any of them. And the answer would be no. Right, we've got 5 volt going to that one as well. Let's just see if we get anything out of that. And the answer's no to that as well. So okay, we've got power going to the voltage regulators, but I guess there's some kind of enable line that needs to be activated for them to start switching. I don't know if it's worth bringing the microscope in just to have a quick look, see if we can see anything. Right, I'll set the microscope up. Right, got the microscope set up, so let's have a look over this board, see if we can see anything. So that's where the power comes in on the USB. I've got a couple of diodes there. Another diode there, possibly a Zener diode, I'm not 100% on that one. That's one of those little power supplies. Let's see what these main chips are. So that's the Zealtech ZT3125. I'm not sure what that one is. And we've got another IC here, which I think that's a General Plus GP326813. So I'll have a quick look, see if I can find a data sheet for those. So we've got 3 transistors or MOSFETs there. Another little power supply, that's the other one, and that's the other one. I can't see any obvious signs of any blown components or anything. Let's just flip the board over. Let's just have a look on this side. Looks like there's... just didn't know whether it looked like there's been something already soldered there at some point. So another little power supply there. I'm just not sure whether that's a mark in the middle of that IC. I'll just try and angle it a bit and try and refocus the microscope. Yeah, I'm not sure whether that's something blown there. So that might be a problem. I'll have to see what IC that is. So that's an MP2307DN. Right, I'll have a look up to see what that is. We'll go another IC here. I think that looks about it. Right, I'm going to have a look, see if I can see what that IC is there. Right, I'm back in one moment. So I've had a look at the data sheet, and this is a buck regulator. So it takes a higher voltage and gives a lower voltage out. And pin 2 is the input, which is this pin here. So I'll just go on here and we'll go on to volts DC, so we get anything on the input. I've still got it hooked up to the power bank. I don't have anything there, so that means we won't have anything on the output either. Let's see where the input comes from then. So it looks like this might just be used for the battery, for battery operation, because it's connected to the battery here. It goes through the diode and then into pin 2. So even if this was blown, it should still work on the USB. So this is probably taking the battery voltage and dropping it down to 5 volts. I think that's what that'll be doing. But why isn't it working? I wonder if it's worth getting the thermal camera out. We'll just connect it up to the USB and then we'll just see what happens when we try and push the power button, see if anything gets warm or anything, or if there's any sign of life anywhere. Right, I'll just go grab the thermal camera. Right, back with the thermal camera. And this is the Coetzee KTI W02. Right, let's plug this in. And it's not drawing anything at the moment. Let's try pressing the power button. Let's try holding the power button down. And doesn't appear to be anything getting hot on this side of the board. Let's just flip the board over. Ah. Well, that doesn't look too good. That's the main IC there. I'll just hold the power button down and we'll see what happens. That's it off. And when I hold the power button down, yeah, that's it on there. Yeah, so that looks like the main IC. That's the only thing that's really getting hot. So that doesn't look very good at all. So if the main IC is blown, we won't be able to repair this. I would have thought because that'll be where the actual program's stored as well. Let's just zoom down a bit. Because there's no flash chip or anything on here. So I would assume that that's where the main program's stored to operate the camera. So if that's blown, even if we get a new IC, we won't have the firmware to reprogram into it. You probably need some special programming or a special programmer to program it. So unfortunately I don't think we're going to be able to repair this one. I mean, I'll just see if I can pull a data sheet up for this and we'll just check that we've got voltages going to it at the right levels. And if we do have, well, let's say I think the chip's fried, which might make sense because if that's the main processor, if let's say for instance we somehow got 20 volts or something onto one of these pins here, which are the USB pins, it would have shot that voltage into this chip here, which has probably got the USB inputs on it as well. I'll double check that though. I'll just get the data sheet. I'm back in one moment. So according to the data sheet, the main power comes in around about here. So let's try on here. and we've got 3.3 volts. Let's try on here, and we've got 1.2 volts. So I think that's right, because I did see on the chip, I can't remember exactly which pin it was, but it said something about 1.2 volts being generated internally. So we've got those two voltages, but that chip's getting warm, so I think that chip's fried. So unfortunately, no fix on this one. So let's go on to something else. A Hubble nursery monitor with pan, tilt and zoom. So I saw this on eBay for spares or repair, and I think I paid around £16 for it, including postage. I'll just bring the listing up so you can have a look. And it says in the listing that it won't pair, so the screen won't actually talk to the camera part. So let's get it out of the box and have a look, and we'll see what it's doing. Take it back to the camera part here. So we've got a couple of power adapters. I guess this is the screen. Let's get the box out of the way. It's still got the plastic on it. Right, let's plug these in. Looks like it's got a returns label on the back there. 17th of the 9th, 24. That looks like the screen is lit up. Plugs in the back here. And we've got a little green light on the camera. So it's obviously got power. And we've got a button on the bottom called pair. So let's hold that down. I've got a green flashing light there. Now how do you go into pairing on this? Is that it? I guess that's pairing mode. How do I go back? So I guess that removes the camera. I don't know why it's got the one with this asterisk next to it. Well, what do you know? It looks like it's paired to... That's better. I was looking for the volume knob there. So it actually looks like that's working. It's just not pairing on camera 1 for some reason. But it's paired on camera too. Why would that be? Why won't it let us remove camera 1? So I wonder if there's anything actually wrong with this. Let's just add it as camera 2 again. So you must always have to have one camera paired. I guess that's the way it works. So can I pair that to camera 1 now then? I go to plus. So I think that's it then. So I wonder if how you move around and stuff. Let's just check if that works. Well, it seems strange how it's been a customer return. It's been back to a workshop or something. They couldn't get it to work. Oh. That's the microphone button, so that works. Yeah. Well, that all works. Well, that was a nice easy fix then. I think it just needed a little bit messed about in the menus and things. I thought this was going to be a bit more interesting than that, but I suppose that's the way it goes. Right then, on to something else I think. A wireless charging nightlight. So somebody brought this into our local repair cafe, and I have had a look at something very similar to this before. It was pretty much the same charging or rechargeable lamp, but it didn't have this part around the bottom. It was just pretty much a wireless charger, and there was a resistor that had burned out inside. So I don't know whether this one's going to be the same or not, and it's just got the additional LED dusk to dawn light on it, or whether it's going to be something completely different inside. So what he said was it's not charging. So I'll just plug this in here. And it doesn't appear to be doing anything. And if I cover this light up, we do get this lit up here quite dimly. The camera's picking up a lot brighter than real life, but anyway, yeah, it's... So I think the problem is in here anyway. So let's see how it comes apart. I'll just zoom down a bit. Looks like we can remove those 4 rubber bones. I've seen a brief flash there. And then we've got 4 Phillips screws. Right, let's have a look in here then. And I can see a fuse just down here. Let's just zoom down a bit more. Hold on. It looks like we have a capacitor. That's slightly domed on the top there. 8.2 microfarads. 250 volts. Put a 25 volt cap there. What? Unless they're dropping some of the voltage, because 250 volts I would have thought it would be higher than that. Well, that looks like that's on the circuit for the inductive charging. Looks like it's on the output possibly. Well, that was the resistor that was blown in the last one. So it looks like the capacitor there. So let's see how this board comes out. I can see a screw there. And I think that's about it. Right, let's see if we can get this board out. And the screw doesn't want to come out. Right, I'll just zoom out a fraction. Oh, they do have some stuff on the other side of the board. There's a few surface mount components as well. So we have a little bridge rectifier there. So I think change that capacitor first, and then we'll see if it springs to life. So 8.2 microfarads. Now I think I have got some of those, but I think they're 400 volts. But I shall go and have a look. Well, I've had a look around, and the only capacitors that I've been able to find are some 4.7 microfarad 400 volts. I thought these were actually 8.2, but they're not, they're only 4.7. So what we'll may be able to do, if we wire two of these in parallel, that'll give us 9.4, which is probably within the 20% of the 8.2, because capacitors have got a tolerance and it can be up to 20%, so 20% plus or minus of the stated value. Now I've just had a look on the back of this circuit, and we've got the bridge rectifier here, and then it goes to that capacitor, so that might just be a smoothing capacitor for the DC, I think. So what I'm going to do, I'm going to pull it out and we'll just test it with the Peak Atlas ESR 70 Gold. So let's just make sure it's discharged. It's a little bit tricky to work on with it being balanced with these wires here. I'm just going to add a little bit fresh solder first. Right, I'll just clean those pads up. I'll just get a bit of solder wick. Right, so that's the old capacitor. I'll just zoom out a fraction more. Yeah. Yeah, so that capacitor is faulty. Let's just see what one of these measures, just to compare. Still quite high ESR, but I think the higher voltage capacitors do have a higher ESR than the lower voltage ones. So what I'm thinking is maybe do something like that and then tag the other capacitor on the back of it. So that's kind of what I'm thinking, something a bit like that. It's just actually holding it together while I solder it. Right, I think something like that might do. Let's try and get it back together now. I just noticed the little sensor isn't in the hole. I'm just going to pop a couple of screws in and then we'll just try it. I mean, I think this will work. I don't see any reason why it wouldn't. It just looks like it's a smoothing capacitor on the output of that bridge rectifier. Just checking the on-off switch still works. Right, hopefully, let's see. Let's try a different socket. Well, it didn't explode. I'm not sure if it's doing anything different though. I'll just turn the main light off a second. So I don't know how you tell if this is even charging. I'm sure this lights up when you plugged it in. So perhaps there's more wrong with this. I should check those fuses. Actually, the fuses must be okay because it wouldn't be lighting up otherwise. Let's see if there's any voltage in those caps, just out of curiosity. No, let's just see if that fuse is intact. Yes. Well, I can't see anything else in here that would really stop it from working. And there's a little switching transistor there. Unless that's failed. I'll just pull this board out of again, we'll just have another look. I've got two bridge rectifiers. We have a bridge rectifier here and a bridge rectifier there. Ah, what's that? That's just where I've soldered those capacitor. That capacitor. I just wondered, I thought there was something burnt there, but that's just where I've been soldering. Let's just zoom down a bit on this and have a look, see if we can see anything. can't see anything obvious blown on here. Let's just have a look on the other side again. I don't think there's really much on this board. Can't quite make the number out on that. I think it's a 1307. One 3091, I think that is. I'm not sure how to tell if the wireless chargers work. Just looking at the legs of that transistor, and they are those three there. So it's a bit awkward to work on this. I'm just going to go on diode check and we'll just see if there's any shorts on this transistor. Now I know you can't see the meter, but I just want to see if there's any. That seems okay. Let's check that the coil's okay. And it is. So I thought I'd just plug it in. So this is actually live at the moment. And I've got the meter on volts DC. I just thought we'd see what would measure across these capacitors here. And I've got about 10 volts. Which I don't think is correct. Why have a 250 volt capacitor with just 10 volts in it? It doesn't seem quite right to me. Unless it's something to do with, I don't know, high frequency switching, and we're just seeing like a small portion of it because the meter's not fast enough. But because I haven't got an isolation transformer, I can't put the scope on this. But no, it's after a rectifier, so it wouldn't be that. So not too sure. I'll just unplug this. I'm just going to have a look to see if I can work out the circuit. Just to see where the AC comes in and where that bridge rectifier goes to, or does. I'm just worried about snapping the wires off this coil here. Let's try it that way. So one of the AC wires comes in here, goes to the bridge rectifier, and then to that side. Where does the other AC wire come in? The other AC wire comes in here, goes through the fuse, through a resistor, through a capacitor, which has got a resistor across it, and then the bridge rectifier. and then it also goes to this bridge rectifier as well. And I think this part of the circuit here is just for these LEDs. And I can't quite make out the colours on that resistor properly. Is that green, blue, brown? $554 ohms. I'm just going to have a look at that resistor through a spyglass just to see if I can see what colours it is. So green, blue, brown. So 561. So 560 ohms, and it measures 554. So that's good. So then it looks like we'll go through a capacitive dropper here that's got this resistor across it. And the resistor's a 1 meg. So let's just check that we get continuity. That's going to be a bit less because of the resistor. Oh. Right, so that pin goes to there. Let's just check if the other one goes to the other side of the bridge rectifier. And it does. Right, a little bit of progress. I just thought I'd pull that transistor there. And if we check it with the meter, we're just going to diode check. So I think this one's the base. We'll get a reading there and a reading there. But if we go across the other way there, we've also got a reading, which we shouldn't have. We should only have a reading that way and not that way. We also get a weird reading that way as well. So that's just not measuring right. So let's just try it on the DC55 component tester, which I repaired in a previous video thanks to the help of Jeremy, who kindly supplied a new pick chip for us. Unknown component or faulty. I'll just try it in my other little component tester here. And again, unknown or damaged part. Now, normally transistors do go short circuit, but they can also go leaky as well. So this hasn't actually gone short, but it's not measuring right. So I've ordered some off Amazon. It was cheaper just to buy a whole box of 200 transistors than it was to buy 20 of these. And 20 of these are in the assortment, so I've ordered those. So when those arrive, we shall fit one and see if it springs to life. Right, back when the parts arrive. Right, it's been a couple of days and the new parts have arrived. So let's get one out. just double check that it's the right transistor. Yep, 13001. I think we'll just compare it to the one that's failed. So let's go on to diode check. Right, so that seems okay. Let's just compare it to this one. Now, interestingly enough, if we measure that way, we'll get the correct readings. And if we measure on this one, we don't. But if we reverse the leads, that kind of measures okay for a transistor pretty much. But it's actually the opposite way around to this one. So it's supposed to be an NPN transistor, and this one's measuring more like a PNP, I think anyway. So that's a bit weird, I've never had that before. So I don't know if you have, so if you have, put it down in the comments, because I haven't. Anyway, let's get this transistor popped in, and we'll see if we can get this thing working again. So let's see which way around it goes. Let's try and straighten these legs up a little bit. It's actually physically slightly smaller than the original as well, I've noticed. Right, I'll just zoom down a fraction. You can see the number there, 13001. Right, I'll just get that soldered in. I'm just going to snip off the excess legs. Right, let's see if it does anything now then. Hopefully I don't break these wires. I'll zoom out a fraction. I think this board's sitting quite in right. Right, I'm just going to pop a couple of screws in again. Just in case it doesn't work and we need to take it apart again. Just checking that the switch works still. Right, I'm going to get the dim bulb tester this time, just in case it decides to go pop on the bench. And I've had a few people asking what it is, and it's just a filament light bulb that's wired in series with the socket. So if there's a short, it'll just light the light bulb up instead of blowing things up, in theory anyway. Right, that's plugged in. Well, nothing bad happened, so that's good. Let's just try it on a normal socket now, because I can't plug the light in when it's centre there. Plug this in. All the way around. Well, it still doesn't appear to be doing anything. Why on earth's that? Let's just see if we've got any voltage in those taps. Well, I've got voltage in them now. And it was more than 10 volts. So why isn't it working though? Now, I remember when I was having a look at the other ones of these, there was some talk about these transistors being different from other 13001s. So I don't know whether these are like a special variant or something, and I'm sure that they had a different pinout. So I'm just going to double check that, so I'll be back in one moment. Right, so I'll just bring up on the screen what I've discovered, that there's a couple of different pinouts of these transistors, which is a bit odd. So I've just taken this one out and I've just hooked it up to the Peak Atlas DC-A55, and we'll just check that it's still okay. This button sticks in a little bit. So yeah, it seems to measure it and find it okay. I'll just try it in the other component tester, just to be sure. Yeah. So I'm going to try this in the opposite way around to what it should be. So we'll try it in that way. Which I know is a bit odd, because you don't normally put transistors in the wrong way around, but there does seem to be two different pinouts. Right, so we'll pop it in that way and we'll give it a try. Right, let's see who's going to do anything this time. And I suppose if it goes pop, it'll just make the video a little bit more exciting, eh? Yes! That's it. Because watch, when we plug it in now, I'll just wait for it to go off. When we put it into the cradle, it's lighting up, that means it's charging. Excellent. So I think that's it. So faulty capacitor and the faulty transistor, which had to be in the opposite way around to what it was supposed to be. Right then, all working. Excellent. I'll just double check that, yeah, because that's the motion detection kicking in. Yeah, so that's definitely working. Excellent. Right, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.